Okay, welcome to day 13 of Advent of Code 2023. So, with this puzzle, we have numbers of grids, multiple grids, and they're full of patterns. Ash as a dot and rocks as a hash, or a pound. So you need to find mirrors, or clusters of mirrors, clusters of the same repeated patterns. So anyway, it tells you how to find them. To find the reflection in each pattern, you need to find the perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. In the first pattern, the reflection is across a vertical line between two columns. Arrows on each side of the two columns point at the line between the columns. So you can see there, at this point, if you're going from the left, at this point, this thing starts to duplicate on both sides as a mirror of each side, except this first column is different. In this pattern, the line of reflection is the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, column 1, which is what I just pointed out, has nowhere to reflect onto and can be ignored. Every other column has a reflected column within the pattern and must match exactly. Column 2 matches column 9, 3 matches 8, 4 matches 7, 5 matches 6. The second pattern reflects on a horizontal line instead, which is just there. This pattern reflects across the horizontal line between rows 4 and 5. Row 1 would reflect a hypothetical row 8. But since that's not in the pattern, row 1 doesn't need to match anything. The remaining rows match 2 to 7, 3 to 6, and 4 to 5. To summarize your pattern notes, add up the number of columns to the left of each vertical line of reflection. To that, also add, multiplied by 100, the number of rows above each vertical line of reflection. In the above example, the first pattern's vertical line has 5 to its left, and the second pattern has 4 above it, so that's 405. Find the line of reflection in each pattern in your notes. What number do you get after summarizing all of your notes? So we're aiming for, with my one, my input, 34100. For their test input, we're looking for 405. So we just need to update the... let's head here. Right, so we have 405 in the test input. I've just got this ready ahead of time. So let's look at how to solve this one. So with part 1, I went with a completely, probably extremely long-winded approach, but let's go through it. So the two things that we're trying to get a total of is the amount of columns before and the amount of rows before. So I'm just going to take those and then we can multiply them later on and add them up as needed. So the total cols before is equal to 0 and the total rows before is equal to 0 as well. Okay, so the blocks are separated by a single line, so we can split those out by double new lines. So we could do for block in string dot split. We want to do that by double new line. Okay, so we want to get all of the rows because we want to look at them individually and we want to look at the columns individually. So let's split out into the rows. So block dot split lines. Cool. So then we want to get the columns as a separate thing. So we have the rows, but at the moment, if we wanted to access the whole column, we'd have to then go over each of the rows for every column. So what I'm going to do instead is just make a new list of strings which represent the column. So cols is equal to, we want to do a list of, so it's going to be the same as the rows essentially. We are going to join, we're going to have line C for line in rows. And we're then going to do that for C in range length of rows 0. Yeah, let's see if that. Yep, cool. That will work. Cool. So then now we have the rows and the columns for the block. We're going to try the rows first, then we're going to try the columns after, and we're going to create a list of potential mirror points. So we're going to have a so we want firstly possible mirror rows is equal to this. And then we want possible mirror cols is equal to an empty list as well. Now essentially we're going to be doing the same thing for both of the rows and the columns. We're going to firstly iterate over them. If the row is equal to the next row, then we're going to append the current row. And same for the column. If the columns are the same, then we're going to append that potential as well. So if we start with the second entry, so if we do for r in yeah, rows, in fact r in so we're going to start from the first one and we want to then just go to the end and we want to do -1. Yeah, so for r in range 1 to the length of rows from the first to the end, and then we're going to do if rows r minus 1 is equal to rows of the actual row that we are looking at, then possible mirror rows dot append that row. Cool. And then we have same thing for the columns. So then what we can actually do is let's try the list comprehension for this one. Possible mirror cols is equal to r for r in range 1 to length of rows. That should actually be row, and this should actually be columns. See, let's just make it that. Cols. Oh no, yeah, sorry, that should be rows. Length of cols, and then we want to just go 1 to the end. In that range, if cols c minus 1 equals cols c. Cool. There we go. And then we can actually get rid of this one here. So there's essentially the same thing. So one, we have we're defining a list, and then we're iterating over the rows and appending the possible mirror rows. And the second one, we're doing the same thing, but we're doing it as a list comprehension. I kind of think the list comprehension is slightly harder to read, putting like so much on one line, but you know, it's more Pythonic. Okay, so we have all of the mirror rows, and we have the potential mirror rows and the potential columns. So if we go for potential row in possible mirror rows, let's just say it is an actual one. And then we'll decide as we go through it, is it actually a mirror row? If it's not, then we'll set this to false. If it is, we'll leave it as true. By the end, if it is true, then we'll add the total rows before to the we can update that running total that we've got. So actual is false, true. So then we want to say if possible row is not none, which it shouldn't be. Shouldn't be none. I'm just looking at some notes. Okay. Let's instead do right, left and right is equal to the rows. We want to go to the possible mirror row plus 1. And then we want to do rows from the possible mirror row plus 1 to the end. So possible row plus 1 to the end. So what we're doing here is we're getting everything up to the mirror point, or potential mirror point, everything from the potential mirror point to the end. And then what we're going to do is we're actually going to reverse the left. In fact, what we could do is just do reversed. Now, I'll explain why we're going to do that in a second. Okay, so essentially we now have a left and a right, which if we're looking at this one, left and right, we could say is the top and the bottom. So as we're going over these, what we're going to want to do is go outwards from here and check that they're the same. Now, because this one is out of bounds, it doesn't have a mirror point, we can actually ignore it. Really good built-in Python function to go over to go over the list and get all of the all of the pairs within it as we go over two lists is zip, and zip will stop at the point of the smallest one. So if we're going out from here, we're going to go this one and this one. We're going to go this one and this one. We're going to go this one and this one, and then stop, because it has nothing else to compare this one to. Now, as we're going outwards, rather than we're going out by 1, and so decrease here but increase here, out by 2, increase here, decrease here, so on and so forth. Instead of doing that, if we reverse this, the left-hand side, then we actually can go over this one and this one, this one and this one. It doesn't look right because obviously they're not reversed, but you get the idea. It would essentially be doing the same thing of going over 5 and 4, then 2 and 6, and then 3 and 6, and then 2 and 7, but it would be going over them in order rather than outwards, like fanning outwards. So that's what we're going to do. Cool. So for left row, right row in zip, zippity-doo-dah, left, right. What we're going to do is say if the left row does not equal the right row, then actual is equal to false, and we're then going to break. We don't necessarily need to break, but we will, just for the sake of it. Cool. Okay, so then what we want to do is this will set it to false if we hit a point where within the bounds that we can get to, we hit a point where it doesn't actually mirror. And if that's the case, it's going to be false. So after it's done the loop, we can then just say if actual, then the total rows before plus equals the possible mirror row plus 1. And the reason we want to do that is we want to count how many are above, but the mirroring point is actually between these 2 points here. So we want to count this one here. So if we're just getting that 4 is the row, because we're 0 indexed, it would be 3. Actually, what we want to do then is add 1, so we then are accounting for that extra one in the middle, or theoretically in the middle. Cool. So that's the rows. Now essentially we want to do the same thing for the columns, except for the columns we want to multiply it by 100. So we've got each vertical line, 100 multiplied by the number of rows. Oh, sorry, it's 100 multiplied the number of rows above each reflection. Okay. Oh yeah, sorry. We're only counting how many there are at the moment. Yeah. Cool. So then we'll just do for potential column in possible mirror cols. Actual is true. Left, right is equal to firstly reversed cols up to the potential column plus 1, and then cols from the potential column plus 1 to the end. For left column, right column in zip, left, right, and you can see that this is actually exactly the same. So a bit of refactoring here could be actually just in fact, let's probably just refactor this. Yeah. So for... Oh, actually, no. Nah, let's leave them as they are for a second. I'd have to think about the refactoring for a second. I just want to get through this one. So if the left column does not equal the right column, then we are going to say actual equals false. We are going to break, and then we are going to say if actual total cols before plus equals 1, and then what we're going to do at the end is then just do total is equal to total cols before plus 100 multiplied by total rows before. Possible miracles. Yes. So all of this needs to be indented, and all of this needs to be indented. Cool. So let's see. Okay. Okay, let's just print PR. PR is 3, PR is 4. Potential rows. Okay. Left, right is reversing. Yep, so we're doing, okay. So let's just see if we ever actually get to here. Print found a match. Print found a col match. Yeah, found a row and found a column. Okay. Oh wait, that doesn't actually do what we want. That's what we want. So let's pop it in there. Found a row match. Didn't find any. Great. Okay. So oh. I think this is the bit that's throwing us out. Nope. Okay, so for the first one here, we have a possible mirror row at the first pattern between the columns. So it's between columns 5 and 6. So let's just print possible mirror rows and possible mirror cols. Okay, 3 and 5 for the first one. Let's put a break in here. Okay, 3 and 4. So we're going to try the rows. They won't find anything. But then we try the columns. But then it's saying potential columns is 5. So for print potential column. Okay, so 3 and then potential column 5. So actual is true, left and right reversed is this. For left and right. Okay, so let's in here, let's do print left column, right column. So this one gave me some trouble when I was actually putting this solution together for Advent of Code. It's just really fiddly. Print not good. Okay, so we're checking 5. That is that. Is it potentially just because of the columns? Is this columns doing what I think it's doing? For line in the rows. So the columns we want so let's actually just check that the columns are being created correctly. Cols. Okay, so we get so the first one we have hash dot hash hash dot dot hash for the first column. So yeah, that is right. Then we have dot dot hash hash dot dot dot. Yeah. Yeah. So that is being done correctly. Okay. So we do have the right columns. So maybe it's this left right. Print left equals right equals left has become an iterator. Oh. I mean, that's, yeah, it's only gonna cause me to not be able to see it correctly. Can we not? Columns. Oh, hang on. Hang on. What if I just did... what if I change this up? Instead of doing reverse, let's just do left dot reverse, which should do the same thing, but I don't know, maybe not. Left dot reverse. No. Still getting 0. Why are we still getting 0? Total cols before plus equals 1. So it doesn't find a row or a column match. What have I done wrong? What have I done wrong? not sure what I have done wrong here. Because we have the potential rows and we have the potential columns. We've gone over those. We've reversed this. So then if we're doing 5, we've got the left of that and that. So what is that even looking at? So if we start at column 5, we have this and this. No, wait. Where's column 5? There it is. So we have dot hash dot dot hash dot hash, which is that. And then we have hash we have this one. Okay, so we got some indexing issues. Left and right is the potential columns. Oh. Okay. So at least got to A point. So we found a column match there. Right. Found a column match. But we only get one column match, so we compare that to that, that to that, that to that, that to that. Found a column match. Right. So because PC is 4 now, that's still fine. Okay, so then the potential rows, we also did negative. So then the second one is a negative. Right. So then we have let's just pop here. Let's just put that in there so we can see where they separate. Right, so we then have these columns. This one we're caring about rows though. So this one we should be doing 0, 1, 2, 3. Row 3, it's potential row 3. So then we basically want to, so we know this one works, we know this one works. Okay, so then in here we want PR is equal to this, print left row equals right row equals Okay, so we have these comparisons. So we get that one, we get that one, we get that one, found a row match. Plus equals, yes, the potential row plus 1. Now we have this issue here of the potential column plus 1. And there we go. Right, that one was a pain. Apologies for that one. For part 1 there, that's taken 43 minutes so far. So if you sat through that, thank you very much for that awful debugging session. Right, okay, so there we go. So we have 34100 and we have the 405 here. Okay, so this is where it gets more difficult. So with this next part, we actually have much more fun problem. So you resume walking through the Valley of Mirrors and smack, run directly into one. Hopefully nobody was watching you, because that would have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Exactly one dot or hash, which could be the opposite type. Or should be the opposite type. In each pattern, you'll need to locate and fix the smudge that caused the different reflection line to be valid. The old reflection line won't necessarily continue being valid after the smudge is fixed. So with this example, first pattern smudge is in the top left corner. If the top left hash up here were instead a dot, it would have a different horizontal line of reflection, which would then be here instead of the column that was here. With the smudge in the top left corner repaired, new horizontal line exists between rows 3 and 4. Row 7 has no corresponding reflected row and can be ignored. For the second pattern, the smudge can be fixed by changing the 5th symbol on row 2 from dot to hash, which makes then a reflection here. Now, I'm not entirely certain why this is the reflection point, because I'm pretty sure when I looked into this there was another reflection point for a column which was really throwing me out, and why no lines reflected above would be better than a reflection point within a column. I can't necessarily see it right here now, but yeah, ultimately this is what is correct, so that's what we're going with. Now the pattern has a different horizontal line of reflection. Summarize your notes as before, but instead use different reflection lines. In this example, the first pattern's new horizontal line has 3 rows above it and blah blah blah. So you're still doing that same 400, same way of doing it, with the rows times 100. So let's go to part 2. Now, I've already popped in the 400 here. Oddly, this is a much simpler set of code that we can use to solve this, but we are going to break out into another function. So with this particular one, let's go over the blocks again. So for block in string dot split, I'm going to split by double new line again. The rows is equal to the block dot split lines. The columns is equal to same thing that we had before, where we're going to take this string, we're going to join it with line. That's not what I wanted to do. Line column for line in the rows. For column in range and then we want to go the length of the rows. First index, first row. Cool. Is that? So that's not closed. There we go. Cool. So then we have the columns. So what we're going to do is create another function called getDiff index, and we're going to use that to find the row index that has the row that has the change. If we can't find that, we're then going to go to the column index, or find the column index. So let's pause there. Let's make the function. So we have def get diff index. We're going to have a list of strings. Let's import that. From typing import list. Okay, so we have a list of strings, and then we're going to say how many allowed diffs we can have, which is going to be 1. In fact, let's just let's not have that, because we know it's going to be 1. So this is going to return an int for the index. Cool. So for let's just say I in range of the length of the array. We'll say count is equal to 0. We're then going to get the left and the right. And so the left is going to be the array to the index that we're on, and then we're going to reverse it. And the right hand side is just going to be the array from the index that we're on. Cool. So for li right I in zip left right. In fact, it's, let's just say for left right in left right. So the current left and the current right that we're on. For the left index, the right index, or character, in zip, good old zippity zip, and then we want the left and the right. Count plus equals int of the li does not equal the right I. I mean, it's character rather than index, but whatever. Cool. So after those couple of for loops, we then just say if count is equal to 1, then we return the index. Otherwise, we return 0. That's basically going to be our function. So we have our columns and we have our rows. We're then going to say row index or diff index. Diff ind is equal to get diff index, and we are giving it the rows. Total plus equals 100 multiplied by the diff index. Diffind, there we go. Cool, and so then if not diff end, then we will do total plus equals get diff index with the columns. So this way, all we've done here is simply go over all of the left and rights, count how many differences there are as we go over them. If we have exactly one difference, we'll return that index. So we're not actually looking for a middle point anymore. We're not looking for a mirror point, which actually we probably could have done something like this in the first one somehow, to make it just a little bit less code than what we did have. But yeah, essentially we get the diff index and we increase the total by 100 times the diff index if the diff index was 1 or more, if whatever the index was, because if it was 0, 100 times 0 is just 0. 100 times 0 is 0. Yes, that's correct. 100 times 0 is 0. yeah, so then if we didn't get a index because it was 0, we then increase it by the columns. So now I've explained, let's see if it worked. And I don't hold much hope. Ready? It worked. There we go. So we have the 400 being correct and the 33106 being correct. So there we go. There was day 13 of AOC 2023. Thanks for spending another hour with me, especially through that horrible debugging session in the end of part 1. But yeah, so there's that. So I've got a few more days that I've finished. So we've just done day 13. So you can see I've done 14, 15, 16, 17. I've not yet done 18 onwards. So yeah, I'll get up to 17, and then if I have managed to get further through these, then I'll make some more videos. But otherwise, I'm just going to go through obviously the ones that I've already been able to solve. Yeah, so 14's up next. Thanks for watching.